Hello kids, now we'll discuss one more the Olympiad problem from Pathfinder. So we have a problem like this. A cup having shape of frustum cone is placed on horizontal floor, tabletop. Mass of the cup is M2. Okay, here the mass of the cup. Okay, somewhere we'll show it acting here like this. Then, and diameter of its bottom is D equal to 10 centimeter. We'll add on that one. The B equal to AB. This particular thing, sorry, PQ. Then the uniform rod of mass 20 gram is placed in the cup as shown, and it is inclined at 60 degrees. So this particular thing is a rod. This is the rod. It is inclined, and this angle 60 degrees it is making with the bottom of the cup. Then the weight of will act here. The weight of the rod will act here. Let it be mg. Okay, then he's asking about the will not turn over. Turn over means should not topple. This word turnover, what is the meaning of that? Not turnover means no toppling. There should not be any toppling. So for that, what is the conditions? So we'll get into the free body diagram. There's a cup. Agreed, everyone? That inside that we are placing this rod. The length of the rod is L and the weight M1G is acting. Here the weight M2G will act. Then about what point it can topple this particular cup because of this rod will exert force on it. The rod will exert force on it and it will topple about point P. The maximum length is asked. The maximum length is being asked. Then there will be a normal contact between the cup and the rod. Okay, call that as say like a N naught. Similarly, on the cup, N naught. Then the normal reaction will pass through the point P by the ground. By the floor, water will open. Now the cup is having tendency to rotate about point P, to topple about point P. Then when the length of the rod is maximum, then the normal contact will pass through the point P. If the rod were not there, then the normal contact will pass through this point P. As the length of the rod increases, then the normal contact will shift. When cup is about to topple, it will topple about point P. This is one basic idea of assuming why about P it will topple. Okay, now we'll take this rod and the cup as system and we'll discuss the net torque about point P. I'll write it here. When as the length of the rod increases, normal reaction NP shifts towards left. And when the system is about to topple, normal reaction passes through P. So therefore, net torque about P should be 0. Let's write down the equations. Net torque due to ohm. Okay, this length is what we need. This length. This length will be how much? L by 2. And this length is L by 2. We'll call this as point dm. The length BD equal to AD should be equal to L by 2. So O will write it. AO plus BO should be equal to L by 2. Then from the triangle, this is AO L by 2 theta. So this length should be equal to how much? L by 2 cos theta. You extend like this. So let this be, say, some ND will. E will write it. And the distance PQ equal to, this is D. Okay, now we'll write down the torque about point P. Net torque about point P should be called torque due to the weight of the rod, M1G into X, anti-clockwise. How it is about point P, the torque due to the weight M1G, you can see this is R bar, this is M1G. So it will be anti-clockwise. And this M1G into perpendicular distance. Then the normal reaction NP will pass through the point P only. So torque due to this will be 0. Torque due to the normal reaction by the cup on the rod, by the rod on the cup. Both will be equal and opposite about point P, these two. So that will get nullified. Okay, I need not to show it. The net torque due to these two normal reactions about point P will be equal and opposite. Now all will be left over now the torque due to only the M2G. And how much M2G should be equal to? Plus M2G D by 2. This will be clockwise. Next again comes, why there is no normal contact? Here also there will be normal contact by the cup on the rod, Na. On the cup, Na. We'll show those things also. Again, torque due to them about point P. Due to these two will be equal and opposite. So we'll write here note. Torque, net torque will be 0 about point P. Okay, what is X? X we can calculate now. This L by 2 cos theta will be equal to X plus D. So what is X equal to? L by 2 cos theta minus D. Minus M2G D by 2. I think we know all the values. Huh? L is what? The unknown thing. So this will be M1, G will get cancelled out. M1 L cos theta minus D equal to M2 D by 2. Substituting all the values, we'll get the required length. This will be our answer. Now do calculation. This will be your answer. So these are some observation a student has to make. The free body diagram. See, once you have, if you draw the free body diagram, then you can analyze. Without free body diagram, without like you're not showing all these forces, and you are learning, and somehow, okay, this equation I'm thinking there's something wrong. You must justify. Okay, this rod is in contact with the cup here. The normal contact is acting. So then why that torque is not coming? Similarly, the rod is in contact with the cup here. Then there's also normal contact at D. Then why there's no talk about point P? Then why the normal reaction will shift? Because it is about to topple about point P. No? So it will, the normal reaction will shift. This is one basic idea of the toppling. No? The normal reaction will shift. Entire toppling, this normal reaction. There's almost in many problems we used it. Okay, these are some simple, even can be asked in advance. It's a Pathfinder problem, can be asked in advance. Very important for